right, testing 1, 2. Volume good in the room? Thumbs up, thumbs down? Okay, great. So I'd like to welcome you all back after that excellent keynote to our first of 2 paper sessions. Today we have 5 really great papers that span a wide variety of areas around new methods and evaluating methods for visualization. So the first paper is from Clara Maria, and it is called A Data-Centric Methodology and Task Taxonomy for Time-Stamped Event Sequences. And just as a reminder, we would like you to put your questions in on Slido. We have some support for questions in the room, but Slido will be one place where everyone can see them simultaneously. So Clara Maria will be joining us virtually, but otherwise we will take it away.
And I will present our paper. I'm Clara Maria Barth, and I will present our paper, The Methodology and Task Typology of Time-Stamped Event Sequences. I have done this work together with Yasara Pairis, Elaine Huang, and Jürgen Bernard. To build tools that support users in specific application domains and problem contexts, visualization designers can use task abstraction and taxonomies. Task abstractions help address specific problem contexts, while taxonomic structures capture individual task characteristics, being generalizable across application domains. However, there are data types that have no data-specific task taxonomy due to the lack of existing best practices. This work is inspired by time-stamped event sequences. In short, TSES, a data type with so far little exposure in the visualization community. A time-stamped event sequence is a sequence of time-stamped events with temporal but no value information. Thus, the primary analysis targets is the temporal data characteristics of the event signatures. This is in contrast to all other time-oriented data types where typically the value is the primary analysis target. Specific data types such as time-stamped event sequences bear common challenges that visualization designers need to address when designing tools for them. The first challenge is that there is no data-specific taxonomic structure which generalizes across domains. This is in contrast to the design study research. Second, specific data types have special analysis tasks, making it difficult to apply general task taxonomies. Third, there is a lack of best practices, leading to a limited learning opportunity. Finally, we also identified a lack of methodological support to even build taxonomic structures for dataset-specific and domain-agnostic settings. To address these challenges, we present the following contributions in our BELIV workshop paper. A dataset-specific and domain-agnostic methodology for abstracting tasks and building taxonomic structures. This methodology will be validated through its application to time-stamped event sequences as a secondary contribution. Our third contribution is a report on triples, which is a novel way to describe tasks. And finally, we present a data-centric and domain-agnostic typology of analysis tasks for time-stamped event sequences. Reflecting on our studies and generalizing them helped develop a methodology for data-specific and domain-agnostic taxonomic structures. The diagram shown here provides an overview of the 5 stages of our methodology: data collection, coding, task categorization, task synthesis, and action target criteria crosscut. While presenting the next slides, I will always present our methodology on the left while presenting its application on the right. In the first stage of our methodology, researchers gather data from 2 complementary sources: a user study and a literature body. This follows a triangulation approach inspired by Nathalie Keracher and colleagues. Using this approach supports the main goal of this stage, which is to arrive at a complete body of tasks. The benefits of this complementary nature of studies are the following. The user study provides a long list of tasks without overlooking individual tasks. The literature study, on the other hand, provides an overview of existing solutions and best practices. On the right, you can see our application to time-stamped event sequences. We conducted an anonymous online survey as the user study, and we looked at papers in the realm of time-oriented data due to the limited number of design studies for time-stamped event sequences. The second stage of our methodology entails coding of two sources separately. The goal here is to derive concepts that turn into tasks later on. Echoing visualization research, we suggest that researchers treat tasks with different levels of abstractions differently. For high-level tasks, we suggest that the researcher uses hierarchical task abstraction, which was pioneered by Yi-Xuan Zhang and colleagues. While for the lower-level tasks, we suggest the usage of open coding, where Matthew Bremer and colleagues are inspiring for its application in visualization research. Regarding our applications, 2 authors were involved in the coding process, while a third author resolved conflicting codes. For the user study, we used hierarchical task abstraction, which you can see now on the right, and for the design study, we used open coding, summarizing the abstracted tasks and requirements. The third stage in our methodology is the task categorization of coded data independently of the 2 sources. The goal of this stage is to group coded study data into more abstract tasks and identify common tasks. Following best practices from human-computer interaction research, we suggest that 2 or more researchers are involved in creating the task categorization. This can be done using either affinity diagramming or card sorting. This and the previous stage were inspired by Heidi Lam and colleagues with their work on qualitative analysis of design studies. Regarding our application, we chose to use affinity diagramming involving 2 authors. The fourth step in our methodology is task synthesis, where we combine the 2 data sources. This join is achieved by using one of 2 strategies, either merging or validation as we call them. Merging should be chosen if the 2 data sources can be considered equal partners, and it will then include joining the 2 sets of tasks. Joining the 2 sets of tasks yields naturally 3 subsets. The tasks identified only in visualization literatures, the task identified only in user studies, and the tasks identified in both. Here researchers can choose which of the subsets to include in their final taxonomic structure. The other strategy one can use is validating a primary source with another source. This can be also done in 2 ways. Either one excludes tasks which only exist in the primary source, for example, or one assesses the frequency of tasks to validate task relevance. Regarding our application to timestamped event sequences, we chose an exclusive merging strategy. The final stage of our methodology is the action target criterion crosscut. The goal here is to arrive at an expressive description of tasks as a basis to be used as design targets. To achieve descriptive tasks, we recommend to use the concept of action and targets proposed in visualization literature. Along these lines, we will present an extension of action and targets as a secondary contribution. On the right, you can see a teaser of our table figure. Its application will be presented a little bit later in order to first introduce all relevant concepts for this table. This leads us to our third contribution. In our third contribution, we present a novel way to describe analysis tasks making use of a triple notation. The notion of triples is inspired by the state-of-the-art notation of tasks, which is often based on the tuples of action and target. Actions describe why users engage with data, while targets refer to what data users seek to analyze. We have identified the tuple notation in visualization research for one, the actions and target by Tamara Munzner, and similar the notion of targets in Hans-Jörg Schulze and colleagues' works. However, we saw a high ambiguity across users' responses for the action and target tuples. Using the task group items as an example, it remains totally unclear how the grouping should be realized. Should we group the items by clustering features or by metadata or even something else? As a result, and a third cornerstone, we introduced the criteria. The criteria describes the means to perform the action on a target. This was inspired by Jacques Bertrand and Nathalie and Gennady Andreevko's notion of targets and constraints. An example showing the expressiveness of triples is rank the action, event sequences the target by feature the criteria. Using the triple notation has the following benefits. Triples are a more expressive and less ambiguous description of tasks. Thus, visualization researchers have a clearer description of their design targets. Additionally, when several types of data and data granularities are involved, the distinction between different criteria is especially useful. Finally, triples can be represented using a matrix notation. Coming to the matrix notation, a matrix notation displays the targets and the criteria of one action on the two axes respectively. Here is an example shown in yellow. It shows three grouping actions which are characterized precisely by triples. The action is applied on different target granularities of timestamped event sequences and based on different criteria. Here the metadata and feature, as can be seen in the matrix notation. The purple example in the matrix notation shows group event sequences using the tuple notation, and it's clearly visible that it still remains vague by what the event sequences should be grouped. Coming back to our previously introduced table, in the table you can see the actions as row, the data characteristics of targets and criteria as columns, and we also show the matrix notation to illustrate the target criteria crosscut for each action. Then we added also a last column that shows the terminal task, which distinguishes between means and ends. This should give guidance on higher level tasks and task combinations in a workflow of a user. Summarizing, we proposed a methodology that uses a multi-strand approach to build data-centric taxonomic structures for tasks. Then we applied the methodology for validation purposes to timestamped event sequences. We presented a triple for the description of tasks, and we developed a data-centric and domain-agnostic task typology for timestamped event sequences. Thank you.
Great. Let's everyone thank our speaker, and we have some questions either coming in through Discord or Slido. So while those are percolating in, so the methodology proposed in the paper, to me, seems to generate tasks that are in terms of, targeted towards specific domains and actors. And to me, one of the things that helps research translate is how you generalize those tasks and connect them from other domains. So I was wondering, what are ways you could take maybe some of these bespoke task taxonomies that come out of your method and then get them to, say, talk to each other? For instance, reuse what we've learned about designing for one specific task in a domain across another domain.
Thank you for your question. So with our methodology, we actually want to be domain agnostic, and we would like to obviously see in the future how our methodology could be applied to different kind of data types, because obviously we developed it thinking of timestamped event sequences, but we think that it is generalizable and could be applied to different data types also.
Yeah. All right. Any more questions coming in either live from the room or on Discord? We can support either. All right. So then a second one coming in is the methodology you present seems to be very general, right? But on the other hand, the examples in the paper are around specifically these timed event sequences. So are there any specifics from the latter in terms of methodology? So I guess building off of the first question, right? Are there things that were unexpected or different or specific to your domain that you didn't expect to generalize?
Okay, so yeah, in our second last step, we actually cross-cut the actions with the targets and the criteria. And the criteria is something that we specifically discovered when looking at timestamped event sequences, because they're very specific tasks. And thus we generated this kind of triple, which should now support and support also these kind of nuances that timestamped event sequences have. Additionally, obviously in the action target criterion crosscut, we use the data characteristics of timestamped event sequences. So in that specific case, there we basically use the event sequences and group of event sequences, as well as metadata and features to perform these crosscuts. Additionally, obviously, because there are not that many design studies available for timestamped event sequences, we decided to include similar studies for our first data collection step, which we then had to kind of, in a way, abstract or like transfer to the timestamped event sequences domain.
Great, thank you. There's a few more questions coming in, but I think we're low on time, so I encourage you to check them out on Slido and answer them asynchronously. So
thank you.
Thanking our speaker again.
Thank you for all your questions.
We'll move, so next we have Mai, who's going to be talking about Creative Visualization Opportunities Workshops, a case study in population health.
Hi, my name is Maïl Chaheli. I'm an assistant professor in computer science at the University of Bradford, and the paper I'm presenting to the BELIV workshop today is a collaboration with Kuldeep Sohal and Tom Lawton from the Bradford Teaching Hospitals, Maria Bryan from the University of York, and Mark Williams from the University of Leeds. And the paper is titled Creative Visualization Opportunities Workshops. Some of you may recognize the name of the methodology, which has been developed by the Viz community, and we've applied this methodology to a case study in population health. So in this talk, I will give an introduction about what is population health management and the challenges it presents to visualization research, the approach that we have taken applying the CVO framework and some preliminary results from this application of the framework and running a series of workshops, and what it implies in terms of potential to characterize the task space for this complex application domain of population health management, and what this implies as key takeaways for us and next steps for us as Viz researchers in order to support this domain. So starting with a definition of population health management, there are many definitions out there, but I felt that this one was the most informative, which is an approach aimed at improving the health of an entire population. It is about improving the physical and mental health outcomes and well-being of people within and across a defined local, regional, or national population while reducing health inequalities. It includes action to reduce the occurrence of ill health, action to deliver appropriate health and care services, and action on the wider determinants of health. Most importantly, what I've highlighted and read in this definition is that it requires working with communities and partner agencies. So going beyond the typical decision-making contexts that we study in visual analytics in healthcare, this area of application for visualization research really goes beyond the boundaries of these healthcare organizations and those clinical settings and starts looking at the wider context of decision-making. With the diversity of stakeholders comes a great diversity of the tasks or questions that people want answered from the data. And one of the examples that we've described in the paper is a task of identifying vulnerable cohorts. And when we spoke to different stakeholders, they had very different definitions of how they define those vulnerable cohorts. And when we tried to map these different definitions or sort of adding that contextual information to the task and tried to map the task to some of the task taxonomies in the visualization literature, like the Andrienko taxonomy, we found that this would map it to completely different set of classes of tasks, essentially. In the clinician's definition, for example, would map it to a direct lookup task, whereas commissioners would define it as something that is more of a relation-seeking task, where we are trying to compare different cohorts and identify those cohorts that have more harmful agents than others. So looking at this diversity also is further complicated by the fact that the decision-making landscape in population health management is really shifting from the traditional siloed sort of decision-making context in which people in education were trying to make their own decisions, people in healthcare were trying to make their own decisions, into a more systems approach to health and well-being. And that implies a huge sort of change and a new way of working, in which we've had quotes from our participants and the people we've spoken to early on in the study who told us that, you know, this new commitment to system-wide working is quite new and is quite difficult for everyone to understand, and how we support that, again, is new. So we were getting some quotes like, so I don't have the answers to a lot of it, I'm afraid, yet. And it was quite difficult to define what the questions that people wanted answered from data were. Finally, the data itself that underlies this whole process of population health management is quite challenging in that we've got this new way of looking at data. So I refer you here to our paper on the connected Bradford data to give you an example of how data can be linked across healthcare, education, social care, community care, criminal records, and housing and environment data. So really bringing a very wealthy resource to support decision makers, and how we can make the most of this is a big question. And that's what led us to the CVO framework, is we wanted to create new spaces for people to really brainstorm ideas and look into this new way of working and how data linkages like the connected Bradford data can support this integrated systems approach in order to establish the health and well-being of a population. We started looking at how we can implement this methodology in two different formats. So we started with online workshops, given that we were during the pandemic, so we were not able to get everybody in the same room. And we had over 100 people participating in these workshops, including researchers, policymakers. And we found that this online format was really useful in the earlier sort of wishful thinking process, especially of the CVO framework, where we had Jamboards, Google Jamboards, where people were putting sticky notes of what questions they wanted answered from the data. We then followed this up with an in-person workshop once we had the ability to get people in a room, and we sat together with academics, clinicians, again, data analysts, and we asked them what they wanted to see as visualizations that can represent the information they need to support this systems approach to health and well-being. We've done some preliminary analysis of the results of the workshops and found some common threads across the different decision-making contexts that are captured in the abstract tasks that we found and the contextual information around those abstract tasks. And we report these results in the paper. We've also found some key takeaways from a biz research perspective. So we found that the CVO framework is very powerful in structuring the conversation with these diverse stakeholder groups in population health management. And we found particular strength of the framework in the divergent thinking stages, which is the earlier stages of the framework, particularly when we were delivering it in an online format where people were sat at the comfort of their own home in front of a screen, thinking really wishfully about all the different questions that in a perfect world can be answered by a visualization. That benefit kind of reduced, though, as we asked them to contextualize these tasks and tell us a bit about some decision-making workflows in which these tasks can be beneficial. But then this was addressed in the in-person format. So we found that this format was particularly useful for that contextualization and storyboarding. So the later stages of the framework. And one of the things we are going to take forward from this work is actually the idea of pipelining these two different formats. So having the earlier stages, perhaps, of the CVO framework implemented in an online format. And then when it comes to the actual sort of later stages of contextualizing and storyboarding and telling stories of data and visualizations and how visualization can help decision making, then that can be delivered in an in-person format. We've also captured some design considerations that we'll be taking forward in our design for the tools that we develop. And these include, obviously, lots of different requirements, but the most critical ones and that are very characteristic of population health management is that this is data about people. So that experiential element is very much captured in the quotes we've got from our participants. And one of my favorite is, the dream is to be able to look at the pathways through services from the perspective of a child going through the journey. This was coming from a service provider. Whereas on the other side, a service user told us that they wanted a message to be delivered visually, that we've got you, we're holding you while you go through this process. So a message of reassurance that they were looking to have through visualization. The other decision consideration to take into account is that, again, the complexities around decision making and the shifting landscape are very much expressed in population health management, and the gap that we know about in the VIS literature between the well-established tasks of sense making and insight generation using visualization versus the actual task of decision making was also very well captured in the quotes that we've received. So the quotes, the examples on this slide are from a decision maker on the left and a data analyst on the right. And they were both talking about the same tool that was recently, it was a commercial tool, visualization tool that was recently commissioned in their service. And the decision maker thought it was quite useless, whereas the data analyst thought it was brilliant. So that's kind of the gap that we are looking to bridge through understanding better the provenance and the process of decision making and the flows of decision making across these different sectors and services within this interesting application domain. Thank you very much for listening, and I'll take any questions. Hi, my name is Mail Shaheli. I'm an
Right, so thank you, Mai. So one question while things are perking in the Slido. So the examples in the paper, right, are design situations that, to me, I don't even know a word for it other than heavy, right? Like the real ethical costs for getting some of these design questions wrong. And I wonder how you balance the sort of deep experiential data you're getting from the people in the workshop with maybe people who aren't represented in the room, right? Like patient advocates, but not necessarily patients themselves. So I'm wondering how those perspectives get incorporated into the design process as it's laid out.
That's a great question. Thank you. Absolutely, it's a very critical thing to include to be as representative as possible in the targeted sort of participants in the workshops. And I cannot claim that we've captured all the different perspectives yet, but we are very much interested in more co-participatory design and more co-production techniques. And we're working closely with our colleagues in different sort of disciplines to build those sort of interdisciplinary ways of working in order to ensure that we're not just doing the typical sort of workflow of a design study methodology, for example, which is great. It works for domain experts. It works for different specific domains or specific sort of, the way we organize it at the moment is kind of like a 2D array where we have domains on the x-axis and contexts of decision making on the y-axis. So we're looking at within these domains and these contexts, sort of who are the key people that we need to be talking to. And definitely we are having different conversations and different perspectives coming from different people. And it's quite challenging, I'll tell you. It's easier said than done, but it is quite challenging to capture as many perspectives as possible and still be able to run analyses, rigorous analyses that tell us exactly what can be shown in visualization. Thank you.
All right, we have 3 questions, all of which are good, but I will have to pick one at random while we have Hamza come up for the next one. They're all good. So deal with them in Discord after this. But in your workshops, this comes in from Anonymous, did you need to do anything to direct effort away from I want this visualization to I want this visualization to do this? So if I can rephrase, like thinking about the end goal versus what are the actual intermediate steps to get at that end goal.
Yes, so this was quite a challenge in the online format. We had this coming from all of our participants. They were not quite able to say, so they were very easy to bring visualizations and put them on the Jamboards, for example visualizations that they knew were useful in one way or another to generate some insights about the data that they were looking at. But when it came to contextualizing these and asking them, well, what can this help you decide, for example, for in your daily practice or for your own sort of decision-making purposes, there was a gap. But this gap, surprisingly, was not as expressed when we talked to the parents and the lay audiences. So they had a much better idea of what decisions they wanted to make for their children, for example, and for themselves. So these kind of individual level decision-making were quite well captured in the conversation with service users. But where it came to population health management experts, there was still a big gap between what they perceived as useful insights and data versus what decisions that can actually lead to. So there was, this is one of the sort of ongoing research areas for us is actually, can we bridge this gap? Can we build better ways to find exactly where these visualizations can actually be useful in day-to-day decision making?
All right, thank you. Unfortunately, we're out of time, but I really do highly encourage you to check out the questions on Slido after. So let's thank our speaker again. And we'll move on directly to Hamza, who is presenting how do we measure trust in visual data communication.
Hi everyone, my name is Hamza, and I'll be presenting the work that my co-authors Eamon Gaba, Dr. Yesel Kim, and Dr. Cindy Xiong and I worked on regarding measuring trust in data visualization. So I'd like you to take a look at these two visualizations. The x-axis shows individual ticket price, and the y-axis shows total profit in thousands of dollars. And I'd like you to think to yourself how much you trust these visualizations on a scale from 1 to 7. Now, you might be quite confused by this question, but this is this is a very common method of measuring trust in visual data communication. Here we can see a paper that measured trust on a 5-point scale from low to high trustworthiness. We have another that measured trust on a scale from 0 to 100. And another paper measured trust on a 9-point Likert scale from least trust to most trust. So I'd like to cover 4 major problems with the one-item Likert scale approach. And I'd like to show you how they can be solved by 4 other approaches to measuring trust from existing social science and psychology research. So the first major issue with the one-item Likert scale approach is that there is only one question. And one question is not sufficient to capture the complex nature of trust. So the simplest way to solve this problem is to add more items to the survey. And we can look to existing psychometrics research by Evans and Ravel that has a 21-item survey with different personality traits that relate to trust or trustworthiness. And we can take this work and modify the items in the scale to apply to visualizations. So for example, item 2 on the Evans and Ravel scale is this person anticipates the needs of others. And if we apply that to visualizations, we can say this visualization provides useful information. So we could show you the same visualizations and ask you to rate your agreement with each of these items on a scale from 1 to 7. The second major problem with the one-item Likert scale approach is that the definition of trust is unclear. What do we mean by trust? How I define trust might not necessarily be how you define trust. So to solve this problem, we turn to trust game research from behavioral economics. And there are many variations of trust games, but we'll look at a voting style investment game today. In this type of trust game, we have a participant called the truster who is given some currency to invest among 2 trustees. Either trustee can have characteristics that make them more or less trustworthy, and the truster can choose either of the trustees to invest in, and the amount they invest will be dependent upon how trustworthy they find the trustee. So in this case, trust is defined as willingness to invest, and the definition has been well tested by behavioral economists in the trust game setting. We can replace the 2 trustees with visualizations, and the currency invested doesn't always have to be money. It can be anything that fits the scenario. So for example, we can use tickets. In other words, I could show you the same visualizations, but now I tell you that each visualization was provided by a different ticket pricing consultant, and you're deciding which consultant you would like to give your tickets to. In this case, the more you trust a consultant, the more tickets you will give them. The third major issue with the one-item Likert scale approach is that the self-report is too subjective. What I think I trust might not necessarily be what I actually trust. And we need a more objective measure of trust. So to solve this problem, let's take a look at the concept of perceptual fluency and how it relates to trust. A visualization has some level of perceivability. In other words, it might be easy to perceive or difficult to perceive or somewhere in between. And that perceivability creates a fluency response. Stimuli that are easy to perceive are more fluent than those that are difficult to perceive. Here we have some examples of fluent and disfluent stimuli. On the left, all of the examples are easy to read, but on the right, they are difficult to read for various reasons, including low contrast, random capitalization, blur, and orientation changes. So this fluency creates an effective response in the viewer. Generally, fluent stimuli are liked more than disfluent stimuli. And this effective response is associated with trust due to the halo effect. The halo effect is when one trait of a subject is conflated with all of their traits. For example, because a person is attractive, one might assume that they are a trustworthy person. So we can ask a question about these visualization that gets at the fluency of the visualizations. To do this, we'll first ask a question that requires participants to interpret the visualizations. For example, what percentage of tickets were sold at the price between $30 and $70? Once they've answered this question, we ask the participants how difficult it was to answer the question. You might notice that the second visualization is particularly disfluent, so we'd expect the task to be more difficult with the visualization on the right. Thus, we'd expect the visualization on the right to elicit more of a negative affective response. Then we ask a question that requires participants to use the visualization to make a decision. For example, do you think you would make more profit or less profit if you increase the ticket price? And then we would expect the answer to be aligned with the first visualization. They would expect to make less profit. The fourth and final major problem with the one-item Likert scale approach is that the scale itself might be interpreted differently from person to person. One person might interpret the scale to look something like this, where all the distances between the values are the same. But to someone else, it might look a bit like this, where the distance between 6 and 7 is much smaller than the distance between 3 and 4. Or even like this, where someone would only pick 7 or 1 in extreme cases. And this can vary infinitely from person to person. To solve this problem, we can measure trust based on the individual's beliefs. To do this, we would ask a question about the person's beliefs before showing them the stimulus. So if your goal was to make the most profit possible, would you price your tickets high or low? Then we would show the visualization, which makes an argument for how to answer the question. For example, this visualization argues that you should price your tickets lower. Then we ask the question again after they've seen the visualization. And if they initially believed that they should price the tickets higher, then they saw the visualization which indicates they should price them lower, and then they change their answer to price them lower. This indicates that they have high trust in the visualization. On the other hand, if their belief initially does not align with the visualization and doesn't change, this indicates lower trust in the visualization. Ultimately, I hope that in our future visualization trust research, we decide not to use the one-item Likert scale approach, and instead use one of the 4 approaches we mentioned today, or some combination of the 4 approaches. Thank you.
We have some Q&A coming in. So the first from Wolfgang Eigner asks, for the multi-item approach, the second question mentioned was, how useful is the information? Isn't this also sort of inherently subjective, just as many as the other trust measuring items are?
Yes, I can definitely see. Let me go ahead and pull up the slide for that. So the second one, or sorry, the second item on the Evans and Revelle scale was changed to this visualization provides useful information. I like to note that these are sort of early attempts at possibly considering how these Evans and Revelle items can be related to visualizations. Ultimately, we would work on this to make them more less subjective, ideally, in our future visualization trust research.
And then another question, marking on 8, people complimenting the aesthetics of the slide.
Thank you.
Right. So, do you think, in fact, as in line with the scatter plot result you showed, do you think the aesthetics of your slide was also an attempt to manipulate trust?
Yes, definitely. The goal of the slides was definitely to make you believe everything that the presentation was saying.
right, and then one last question, and then we'll transition. But there's plenty more to look at on Discord when you get a moment. So for the trust game, this is from Kyle Hall. For the trust game, trust seems to be related to risk. So return on investment could be another factor that contributes to selecting a trustee. For disparate visualizations, could we have similar issues? Right. For instance, I don't trust this viz as much, but allows me to do far more, so I will use it.
That's a good question. There are other, so risk as a method of, as an aspect of why you would choose one visualization over the other. I'd need to think about that a bit more, but I think that might be something that we would want to look at when you're deciding to use any of these four methods or any combination of them. You need to ensure that the trust game that you're using and the visualizations that you're using are not eliciting some other reason for why they would choose a particular visualization.
Thank you. All right, so let's thank our speaker again. And the audience could keep questions coming. This has all been really great. So our next speaker is Tomas, who will be discussing how personality and visual channels affect insight generation. Oh, and check the audio real quick. Yeah. Escape out real quick. Just gotta make sure it's going through the sound. Yeah. Sorry. Oh, okay, that's right. All right. Turn that up a little bit. Oops. Thank you. All right. I think we're good. Let's go.
My name is Mazal, and I'm going to present our work titled High Personality and Visual Channels Affecting Insight Generation. Gaining insight has been considered one of the major purposes of insights. Further, several researchers have stated this evaluation beyond traditional measures, such as task Hello. My name is Mazal, and I'm going to present our work titled How Personality and Visual Channels Affect Insight Generation.
It's not coming through.
Research should promote insight extraction to amplify our understanding of analytical reasoning. Green and Fisher define insight as anything unexpected or novel learned by the participants while completing the test. There are already specific types of insights such as correlation, fit, and outliers. Researchers try to establish a taxonomy. First, Chen and all define insights into 12 analytical types. More recently, Moore et al. Further studied insight categorization to provide robust guidelines for practitioners focus on the process of gaining insight into data. In his work, he wants to further understand its methodology and study which obstacles exist towards the. Hello, my name is Mazal, and I'm going to present our title How Personality and Visual Channels Affect Insight Generation. Gaining insight has been considered one of the major purposes of insights. Further, several researchers advocate diversifying evaluation beyond traditional measures, such as test completion time and accuracy. In particular, research should promote insight extraction to amplify our understanding of analytical reasoning.
Okay, I will share from Zoom.
Green and Fisher define
we're still not getting sound through the Zoom.
Hello, my name is Tomas Alves and I'm going to present our work titled How Personality and Visual Channels Affect Insight Generation. Gaining insight has been considered one of the major purposes of InfoVis. Further, several researchers advocate diversifying evaluation beyond traditional measures, such as task completion time and accuracy. In particular, research should promote insight extraction to amplify our understanding of analytical reasoning. Green and Fisher define insight as anything unexpected or novel learned by the participants while completing the tasks. There are already specific types of insights such as correlations, peaks, and outliers. Research has tried to establish a taxonomy. First, Chen et al. Divided insights into 12 analytical types. More recently, Moer et al. Further studied insight categorization. However, there is little empirical data to provide robust guidelines for practitioners focused on the process of gaining insight into data. In this work, we want to further understand its methodology and study which obstacles exist towards the practical use of insight-based methods for evaluating visualizations. First, we tackle the categorization model. As we mentioned, Chen et al. And Moer et al. Already developed two models. However, we want to understand if and to what extent the insight categorization model affects the descriptions of insights based on the same corpus of responses. Further, research assumes that the user profile follows a one-size-fits-all strategy. However, recent research has shown that no two users are equal to one another. Among the individual differences, we can find visualization literacy, cognitive traits, and personality. Personality is a set of habitual behaviors, cognitions, and emotional patterns that influence the construction of a mental model. Moreover, it is a stable construct throughout one's life. Recent research highlights how this construct affects user interaction with InfoVis, and Green and Fisher have shown that the same happens in insight-based evaluations. Our work attempts to validate and expand the research question on whether personality affects the insight generation process. In our work, we focus on the 5-factor model, otherwise known as the Big Five. The next part of the user study was to choose which chart types the participants would interact with. We decided to use hierarchy charts. All should differ in channels and encodings, making it important to choose visualizations that are able to represent the same dataset. We opted for a Sankey diagram, a tree map, and a sunburst. Moreover, we defined that the visualizations will have 3 hierarchy levels, starting from the root, then designated as upper, middle, and lower levels. After developing the visualizations, we recruited 51 participants, 25 male, 26 female, aged around 28 years old. Regarding the user tasks, we asked the participants to complete in a random order, per chart type, the following tasks. First, which category has more subcategories? Which city has the middle level with the largest number of lower level instances? Which is the lower level with the largest number of domain units from the middle level instance? How many domain units are there in an upper level instance? And finally, how many domain units are there in a lower level instance from a middle level instance? After the participants interact with the chart, we asked them to report any insight they could collect from it. We also collected 5-factor model trait scores and some demographic data. Participants generated a total of 313 insights. In particular, each participant reported between 0 and 16 insights and around 6 insights per person. Participants generated slightly more insights in the Sankey diagram, followed by the sunburst and then the tree map. Now, regarding the obstacles for insight-based evaluations, we started by tackling the categorization model. We recruited coders to categorize each insight based on Chen et al.'s model, as well as Moer et al.'s, and another model that we defined as the insight valence model. This model tries to categorize an insight based on the valence that it transmits, meaning that when the insight is positive and praises something, it's positive. When there's a negative evaluation, it's negative. And when it's just a factual insight without any valence, we classify it as neutral. Now, comparing the models between themselves, we can first take a look at Chen et al.'s and Moer et al.'s. First, we can see that analytical insights are more prominent in Chen et al.'s categorization model. In fact, it takes around more 10% analytical insights than Moer et al.'s, meaning that for the same corpus of responses, Chen et al.'s categorizes some of them more as analytical than the other model. For instance, if we take a look at these two insights, each city can have more than one desert, and there are many shapes of grain sands. We can see that Chen et al. Would classify them as distribution, and Moer et al. Would classify as plane. This difference in classification means that while Chen et al. Would classify this as an analytical insight, Moer et al. Would classify them as non-analytical insights. Further, if we want to compare whether there's any emotional content on the insight reporting, we can see that Chen et al. Classified almost 50% of the insights as emotional, while the other two models, Moore et al. And Insight Balance, classify about the same number of emotional insights, meaning that, again, there's a discrepancy in the distributions based on the same corpus of responses. We can conclude that the categorization model chosen for the insight evaluation may introduce noise in the study results. Therefore, we believe that the next step is to conduct further research to create and validate a new model. Regarding personality, these are the lowest lines on top of scatter plots showing the distributions of number of reported insights per chart type. Our results show that the openness to experience rate has significant effects on the number of insights that people reported. In particular, it is a positive influence, meaning that as people have higher openness to experience scores, they will report more insights. These results complement the work of Green and Fisher and show that personality may also introduce obstacles in insight-based evaluations. We believe that researchers should enrich the user profile prior to the experiment and control for these individual differences. However, our work has limitations regarding the sample size, which should have been larger to produce more effects. Next, personality results should be further validated to confirm whether our results and Green and Fisher's apply for the overall insight-based evaluations. Finally, more data types, charts, and tasks should be considered in this type of evaluations. Thank you all for your attention, and you can read more details in the paper. Hello, my name is Tomás Alves, and I'm going to...
Let's thank our speaker.
Hi, thank you.
And apologies for the technical difficulties. I've been assured I do not have a future as an ambient sound DJ. So
it's okay.
So we have some questions coming in. The first one I wanted to ask was, okay, given the differences you saw in your studies between the taxonomies that you used and the personality traits that you measured, there's the little anecdote, right, that software companies ship their org chart. So when we measure insights, are we just shipping our insight taxonomies, right? So when we claim we're measuring insights, what do you think we're actually measuring?
So what we're trying to collect when we're measuring insights is whether people actually could extract information from the data and realize something new, or conduct any specific analysis from the charts and then gain new knowledge. So that's what we will classify as an insight.
Yeah, and so I'm just to add a little clarification to that, right? Like, so often, like in our heads, right, the idea of an insight is this like deep, qualitative, longitudinal, aha moment in the data. And do you think the tools that we currently have are those, do those cut it, right? Are those sufficiently good to kind of measure the phenomena that we want to measure? Kind of in line with the previous paper, right? Like, are we in our one item Likert scale phase of measuring insights?
Yeah. Can you please repeat the question?
Oh yeah, so the question is, what are we measuring, and when we think we're measuring insights, is it actually the thing we want to measure?
I would say that when we are actually measuring insights, we are kind of trying to measure whether people, after conducting some analysis, whether they could gain the knowledge and understand what are the charts trying to convey. Like, can you actually understand what you're seeing and the information that's being displayed?
All right. Okay, and then another question from Anonymous, it looks like, on Slido. What test did you use to measure the big 5 personality traits in your study?
It was the NeoPR, the revised version. So the 240 items.
Okay, and then one last one, and then we'll transition to our last speaker. From Francis Nguyen, asking, how do you think other levels of expertise, like statistical literacy, visualization literacy, or other prior knowledge or context, intersect with these personality traits?
We actually measured whether user familiarity with the charts had any effect on the insight generation, and we could not find any significant relationship. But I would say that if people have a higher visualization literacy with some chart types, then I would expect that they could access and extract more insights from the visualizations.
Okay,
But
great.
I think the part that needs to be further validated is how do you access the user literacy with the data? That's the biggest issue here, I think.
So follow-on work for you to do that. All right. So we're out of time, unfortunately, but there are some more questions if you want to address them on Discord or Slido. So let's thank Tomas again.
Okay. Thank you for the questions.
Right. And our last but not least talk of the session will be our in-person talk from Kunal, and he'll be talking about evaluating situated visualizations with eye tracking.
Okay. Hi. So my talk today will be about situated visualization in AR with eye tracking. So I want to talk with you why it would be useful to use for evaluation procedures of your techniques in augmented reality eye tracking technology. So if we talk about situated visualization, the cool thing about this is that we can show data visualizations in the context, in the spatial context where the data is coming from. Or we can at least present it in some kind of immersive environment where we have some spatial references that we can investigate in more detail. And we can do this with different devices. In the past, this has often been done with handhelds, where you can move around and see some data projected on objects in the real world, for example. You can use projections for that. You can also have some applications with physicalization, where you print data. Or what I want to talk in this presentation about is using head-mounted displays, because right now this is the most convenient way to do this. As you can see, for example, with these HoloLens here in the background. And one example for this is this project that we had, where we have an assembly line where most of the stuff is producing individual steps of a product in different stations. And all of these stations send data to a central server, and the machines notify you when something happens, and you have to react to it. So we developed an augmented reality visualization that helps to see where something's happening and what is happening and helps to navigate. And you have an additional tablet that gives you more details with additional visualization techniques. So, but I don't want to talk too much about this because my colleague Michael will present this on Wednesday in the CGNA session. So if you want to more know about this, please go to this session. The main question I want to talk about here is how do we evaluate such techniques? That's the more complicated thing that we have to address in the future. So when we look at evaluation scenarios in general, we can do similar to the scenarios that were introduced by Lam and Isenberg and colleagues, something for augmented reality scenarios, as it's been done by Marino and colleagues. And these were, for example, the evaluation of algorithm performance, qualitative result inspection, user performance, user experience. And the later points is more about understanding the processes in general, understanding the environment and the work practices, team communication, and team collaboration. So when we look at usual evaluation procedures, this is based on performance as it's classically done, algorithm performance, user performance. And as you remember the name of this workshop, we want to go a little bit beyond that. The other points are mainly addressed by qualitative techniques, interviews, and observations. So this is where eye tracking comes in. And I would argue that eye tracking can help especially to evaluate these later 3 points. And it has qualitative and quantitative aspects. So if we talk about the benefits of eye tracking in general, so the first thing is that if you use some hardware like the HoloLens 2, then you already have it and maybe just not using it so far. But it would be beneficial if you want to find out how do people solve tasks you give them. And for this example here, we just had in our basement a small art gallery with visualization artwork, and we asked people to walk around there and recorded how they inspected these techniques. So there was not per se already augmented content in it, but we just wanted to showcase you how to present eye tracking data and how to process it here. Qualitative aspects here is that we get from each participant that we record an individual video with their egocentric view, so you can watch through the eyes of your participants how they solved the task and where they were looking at while they were doing it. And we can aggregate gaze distributions, like you can see on these heat maps here, so you can see how on your environment or in your components that you presented there, where the people looking, maybe which information did they miss or did not look so long at it. And this is also where the quantitative aspects come in. With eye tracking, you can measure fixations, you can quantify how long did they look at specific areas, what was the frequency that it was visited. And also with the saccades, you can see how much eyes were moving around, which could often be an indicator for confusion, for example. So if you want to do so, there are quite a couple of challenges to apply eye tracking in augmented reality. So far, we've done a lot of research on how to do this in desktop scenarios where you sit on your computer and do something with visualization. And now, as you can see, we have people moving around in an environment, and we have to address this a little bit differently. So the first challenge is semantic mapping. We can usually see, or we have to identify what people looked at. And for virtual content, as we have with augmented content, we know what we are rendering. So we can identify this and do some hit detection when people look at it. We know, okay, they looked at this virtual content. This is something we can derive automatically if we prepared our data that way in the beginning. If we have real objects, we have a little bit of a problem. As you can see here, this is a mesh that was created by the HoloLens while we were looking around in our basement. And in this mesh, so far, there is no semantic information. So it does not know which are the pictures here in this mesh. That's something when you don't have an algorithm that detects that for you, you rely on on manual annotation, and that can become very tedious. If we have this, the benefit would be that we could create context-aware visualizations where you can really interact with your environment, even if it's not augmented content. And you have semantic labels that you can use for classical scan path analysis, where you can analyze, for example, sequences, orders in which people looked at different objects. The second challenge is the spatial mapping, where we have to match multiple models. If you put on your HoloLens on your participant, let one move around, record this, then get another participant and do the experiment again, you will get a lot of different coordinate systems that you have to match somehow. There is a lot done in this area with spatial anchors, where you pre-register some information and then can match these models together. And as you can see in this example here, you can also include additional models. The mesh from the HoloLens is not so detailed. So what we did here, we created a photogrammetry model with a lot of pictures here that allows you to basically reconstruct the environment in a more photorealistic way, and that you can match together with the other models to create some kind of databases for further analysis. And the benefits here is with unifying them all together here, this brings you a comparability of participants and is basically your databases where you can do visualization for real-world context and augmented context. The third challenge is the spatiotemporal overview. When we want to compare participants, how do we do that? So the third challenge I would see more as the kind of visualization question here. How do we show this? How can we interpret this? We have a participant moving through some spatial context. Over time, we have trajectories from the person and also trajectories from their eye movements. So these are two types of trajectories that come together here. And the spatial context together, that might lead to visual clutter very fast if you have 10 or 20 participants you want to compare here. So I would say there is definitely a need for new techniques to develop here. And the benefits would be that we have some kind of static overview where we can start from with our analysis and detect visually where important events might be. Where did something happen that's worthwhile investigating in detail? The fourth challenge is if we don't have one participant, but also a moving environment. So let's say, the simplest example, another person that moves around with you, where you do some collaborative tasks. How do you track these other components that move around? These are additional trajectories you have to consider. And if it's not someone else wearing another HoloLens that have tracking, you need some additional sensors or something where you can also track those and create trajectories for later analysis. Of course, if we had something like this, it would be beneficial to include more application scenarios and would also allow, if we know more about our environment, to include more user-environment interaction. And the fifth one is the most challenging one, I would say, the environmental scale. So what examples I showed you, this is from a small basement. If we go up now to the whole building or to a whole city, all the challenges I mentioned so far come back here just on a bigger scale and even more complicated. So that's really a problem. And if we would have that, we could do situated visualization in the wild, which would be really cool. If we talk about application scenarios, we have the manufacturing in Industry 4.0. So just as a reminder, go to this session on Wednesday. We could also apply this for architectural design and construction, not just industrial machines, also buildings become more intelligent and send data all the time. And somehow this has to be addressed. And spatial context is here very important. Also, my other colleague, Mortas, will present in the same session some examples in this context. And the other one is we are also based our scenario on is education, where you have, for example, exhibition layouts and want to optimize this. The last one is some more futuristic one. If you have personal visualization, you can imagine these devices are live logging devices that you could use to measure also crowd attention in some spatial context. Okay, to conclude, situated visualization in augmented reality is challenging to evaluate. And what we want to find out is how do people move and look at situated visualizations here? In eye tracking with head-mounted displays, we already have this technology possible, and I think we should use it. And with some additional libraries, you could easily integrate this into your studies. And it provides you a rich source for qualitative and quantitative evaluation. If you want some takeaway message from my talk, then I would say visualization in AR requires new ways of evaluation, and eye tracking is a powerful means to better understand how people perceive and interact with such techniques. So, thank you.
Thank you, Kuno. All right, so we have a few questions in. So one is from Wolfgang Agner, who asks, are there any insights you gathered regarding switching of user gaze back and forth between the abstract visualization and the actual physical context, right? So the real object and the surrounding versus the augmented visualization.
So in the example that we showed, we did not have any one. We did another experiment where we included also the augmented content. I would say it really depends on what you're looking for. If you want to find out if the augmented content really helps to understand. So for the pictures, you could imagine that we have some additional information that did not fit on the description box, the small ones that are next to the pictures. Then you could evaluate with such techniques how long did people look at it, how often did they look between augmented and real content to really understand what they were reading and checking back and forth. So that would be one example I could imagine here.
And then I suppose a follow-on to that, do you expect patterns of gaze and use to change over time longitudinally? For instance, the first time I put on an AR app, it might be very different information foraging experience than the 100th or the 1000th time.
Yeah, definitely. I mean, also when I was using this, it needs time to get used to it. And especially if they got better, but they are still a little bit bulky. You have to deal with this first, and if you get used to it, then I would say from the personal experience, it gets easier to work with this. And yeah, longitudinal, I would maybe not use this. so I would not wear it over the whole day since it's still a little too late. If we get new devices that might change, and then we would have to reinvestigate, I would say.
Great. Last question, and then we'll be out of time. What about using AR in research to elicit reactions? So I guess that's that's affect. Right? Is that sort of a realistic setting, or is that not commensurate with what the actual use is?
Yeah, because that's tricky. I would say with eye tracking, you will not get everything about reactions here. So you would have to include other measures. But still, with this additional information of spatial context, you could at least find out when or what in the environment caused this. If you measure something based on heart rates or so, then you have more contextual information. And I think this is what would be the other thing you would do. You would record maybe some video and then analyze later on what happens. And here you have a little bit more information, especially regarding the spatial context.
Thank you. All right, so let's thank our speaker again. And then I would also like you, if you're not too exhausted by clapping, to thank all of our speakers in our session collectively. And with that, I will let you all get your much-deserved lunch, and we will be back here at 2 p.m.